Thank you very much, everyone, for attending this talk. So today, I will be discussing about a buzzword, a technological buzzword, which is probably competing with Bitcoin nowadays. But it's going to be the talk of today will be about artificial intelligence, its application for supply chain, and maybe for the Franco-British Chamber of Commerce, maybe an angle that would be of interest to people that are there, maybe the evolution for society at large as I see it, probably with some angles that are relative to France and Great Britain, which happen to be two countries that I know. I know France more than Great Britain, but still we have a lot of clients in Great Britain as well. So let's start with AI, artificial intelligence. So what is it exactly? You will find plenty of people who are describing, I would say, human level intelligence or even superhuman level intelligence, but the reality is very different. So nowadays, so first, artificial intelligence is just the continuation of progress that have been made over the last literally 5 decades in machine learning or statistical learning or high dimensional statistics. All of that is more of the same thing. And so although it has become a buzzword, there is nothing very fundamental that has happened specifically in the last 2 years. You know, progress have been ongoing for decades. And there have been very spectacular achievements, but it was not that, you know, just like one discovery at a point of time. It was more a stream of small things. In computer science in general, progress is very, very incremental. And it's the same applies for machine learning and AI. So when people say AI, I think they basically refer to nowadays to one specific mathematical theory, or I would say statistical theory, that is called deep learning. So has anybody heard of deep learning before here in the audience? Maybe some? Okay. So deep learning in short, so that we know what we are talking about, deep learning is really about learning from data. So it doesn't change from all the automated learning tricks and strategies that we have. It's about learning, extracting knowledge from data. It's about extracting knowledge from data in a very high dimensional way. So you want to have data that has a lot of dimensions. So for example, an image is a very high dimensional object. It has many pixels. It's the opposite of, let's say, a survey with 3 questions. You know, 3 questions, you have 3 dimensions, and you want to do, you can do your PCA analysis, principal component analysis, or, you know, that would say old school statistics. So statistics, traditional statistics works if you have like a couple of variables. But if you have like thousands or even millions of variables, typically performance falls apart. And that's where modern theories like deep learning really shine. They can comprehend, they can work with very, very high dimensional problems. So what is interesting is that we have those progress, and we have been, I would say, some of the breakthrough were actually not coming at all from, I would say, mathematics or statistics. That was just from the hardware. So for example, one of the key ingredients to make this AI revolution happen was actually gaming cards, you know, high-end graphic cards called GPUs, you know, graphic processing units. Who is a gamer? Maybe nobody here? Who plays video games? I play video games. So the idea is that those high-end graphic cards have been recycled for advanced statistical analysis. And it happens that with the proper mathematical framework, they are very, very good at it. It's really a matter of opportunistic recycling. You know, those graphic cards were never designed for AI in the first place. And what is very interesting is that very, very state-of-the-art actors like Google are now designing their own hardware to support AI. So that's typically called tensor processing units. So you will see more and more in the future, and that will be very relevant for supply chain, by the way. So why? Because those graphic cards, they are very, very good to run those statistical models. Remember, it's all about statistics. They are very, very good, but they consume a lot of processing power. Power, raw power, electricity, which means that, for example, if you want to have like an autonomous vehicle, do you really want to have the AI on board that consume 1 kilowatt of power? Maybe not, because you want to have like an electric vehicle, so it will be on battery, and you don't want to add 1 kilowatt just for the AI autopilot system. Just to give you an idea, the human brain consumes about 50 watts. So you're about, your energy consumption of your body is about a light bulb. So humans are very, very lean in terms of energy consumption. Right now, AI, what we have, it's very not lean. And we are trying to get better with dedicated hardware, but we are not quite there. It's coming to the market. I mean, obviously, the future is not evenly distributed. Google is probably, and Facebook are probably ahead of the pack. But it will require specific hardware, not just high-end graphic cards for gamers, and it's coming. Okay, so that's basically what AI is for. And before delving into the application for supply chain, let's immediately point out the limits. Where do we stand in terms of capabilities? What are the present limits of AI? The main limitation is right now the data efficiency. So that means that we have classes of statistical models that, if given a lot of data, works very, very well. But you need to have literally a lot of data. When I mean a lot of data, you will see, I mean really massive amount of data. So by the way, one of the ingredients that has fueled the recent success of AI is big data capabilities and cloud computing, because you need to have platforms to just manage all of this data. Like I'm talking of terabytes of data, petabytes even in some situations. And so you need to have like the infrastructure to just store and process the data, and that requires cloud computing infrastructure with big data software on top of it. So that's a requirement to make many of the things that are, I would say, AI-driven work nowadays. So that's very interesting. So AI is not in isolation. It really depends on a few other things. So just to give you a taste of what I mean by data efficiency, if you want, for supply chain, let's talk about, for example, autonomous vehicles. A human can learn how to drive in pretty much 20 hours. So you see, you never hold the wheel in your entire life. You just start, and after 20 hours, you will be probably not an excellent driver, but you will manage. And the thing that is a bit insane at the present time is that if you have a look at what companies that are very strongly investing in autonomous vehicles, we are talking of models that are literally crunching like 1 million hours of driving. So you see, to reach a point where the machine can drive as a human, it takes 1 million hours or something. It's as if it was taking 500 years of experience to start to manage to drive a car. You see that, yes, we are capable of learning, but it's not that good. It's like super, super slow, like super, super dumb, actually. We are literally brute forcing our way into learning anything, which it's my personal opinion, as I would say, a machine learning researcher, is probably the statistical theories that we have are not the end game. There are many, many things that we do not understand about the very process of learning. There are many, many things that are just completely eluding our grasp, and so we have solutions, but that are like very crude brute force attempt. So, which means also that there is a lot of things that still elude us, although they are seemingly not that complicated, but it's still very, very, very difficult. For example, bipedal walking. So you have a robot that just walk in a fluid manner. It's still very, very hard. Although any toddler is pretty fine at the age of 2, you know. And many animals are just fine, like within hours after birth, or even minutes for some. So obviously, there is a lot of room for progress. This is not the end game. This is merely the start. Now, an interesting thing is that the limits are typically also not what people think they are. Just to give you when you have a lot of data, literally a lot of data available, you can do things that are almost superhuman. So just to give you a very recent paper that was published late last year by Facebook AI, that is called like monocorpus translation. So Facebook, the teams at Facebook have built an algorithm that if given text, a corpus of text that was in French, a corpus of text that was in English, no translation given. So you see, it's just a big pile of text in English. They literally worked on a big pile of French text, big pile of English text. It will directly learn an automated translation system from French to English. No translation given ever. The only thing that you need is to have like a lot of text in French, a lot of text in English. And this is very, very surprising. It means that translation can be completely learned out of nothing if given enough amount of text. And guess what? Facebook has access to a lot of things because they have all the discussion and text that are happening on Facebook itself. So they have like an unlimited amount of text written in French, although maybe the spelling on Facebook is not top notch. And similarly, unlimited amount of text in English. So when you have literally unlimited amount of data, you can learn things that are surprisingly superhuman. Just think of it as if all you had to learn English or French, depending on what is your mother tongue, was access to a large corpus of text. That would take you a lifetime to learn how to translate the thing. And now it can be done completely automatically. So that's very, very puzzling, but also it reflects a bit that the limits of AI are really probably not the one that people think they are. They are strong limits, but they are very counterintuitive. Okay, so now getting closer to supply chain, what can we expect in terms of transformation for companies? And here things get very, very counterintuitive, I believe. If you look at science fiction and anticipation movies and this sort of stories, the typical fallacy goes that you see society or the market just the same as it is today, but with a few things that have been replaced. And this is typically my own experience is that it's really not the way things happen. Just to give you some background, here in this very city, like a couple of centuries ago, one of the main jobs in Paris was to have people that were carrying buckets of water. That was like a 2-digit percentage of the population in Paris. The employment in Paris was about people that were just carrying buckets of water. And they were completely replaced and disappeared by running water. So the solution took a form that was completely different from, we didn't invent a robot to carry buckets of water. We did invent running water, so innovation came, but from a form that was very, very different. And there is a very famous quote from Henry Ford, is that if I had listened to my customers, I would have tried to breed faster horses instead of building a car. And I think that AI is exactly that. So what will maybe AI-driven stuff look like? Well, for companies, I believe that companies nowadays are trying to compete on many angles: creativity, performance of whatever. If they have like something like a chemical process, raw physical performance at what you're trying to achieve, or brand, but also cost and productivity. I believe AI will be mostly a matter of increasing productivity. I mean, yes, we have some angles where people are starting to use AI for creative purposes. I think it will play its role. There is plenty of techniques where you can generate image and sounds, etc. But I think it will be more, if people are using AI for creative purposes, it will be more a way to supplement the artists rather to replace them altogether. It will be just another tool for their special effects, and so that they will be able to work faster at generating very cool creation, music, videos, new forms of art, I don't know. But I think for society at large, I think the biggest impact will be in terms of, especially for companies, will be in matter of productivity. And obviously in supply chain. So where the 20th century was all about improving the productivity of the manual work, the labor work. So productivity in the 20th century was about automating everything that was requiring, I would say, physical strength. It's very interesting nowadays. We have moved from a society where, beginning of the century, of the 20th century, it was a physically exhausting work to work in a factory, to literally nowadays, even factories that are not that automated, you don't need raw physical strength. I mean, if you want to lift something that is heavy, you will just use a pallet lifter. You're not expected to be physically strong. There is almost no jobs anymore, except maybe in craftsmanship, that requires raw physical strength. So these things have been, I would say, there are still a few things that lingers. That's why we have this discussion about pénibilité, in French, about work that is stressful for your body, but the reality, it has become very rare. I mean, maybe less than 5% of the French workforce and British workforce is really having a job that is very demanding on their bodies, at least physically. I'm not saying in terms of stress or anything, but on their bodies, it's rare nowadays. So that was really the things that happened in the 20th century, is to deal with the physical work. What is interesting for the 21st century, I believe that the biggest change will be to automate all the clerical work. Because it's very funny, as our societies and companies were getting richer, there were less and less people in the factories, less people in the warehouses. I mean, just to give you, for example, in the warehouses, it's staggering, the progress. La Redoute, a very, literally a century-old company, French company in the north, has announced publicly on LinkedIn that the new warehouse is having 20 times the productivity, how many, compared to the old one. So it means that to ship a parcel to a customer is going to take 20 times less seconds to prepare and everything than the previous one. So, the warehouses are now incredibly robotized. They are like just a gigantic robotized machine. I mean, they can be made so in many domains. And the productivity is just completely, I would say, mind-blowing. It's literally a big machine where you have a few people to supervise, but I'm not saying, I mean, it still requires a lot of people, but almost nothing compared to what it used to require. And so it's interesting because as those companies were getting richer, what did inflate a lot was a sort of bureaucracy. That's what I would refer as a Excel bureaucracy or PowerPoint bureaucracy. And in pretty much all the large companies we are talking to, they have now more white collars in their ranks than they have blue collars. Factories are automated, warehouses are automated, transportation is on the verge of being completely automated. I'm not sure if you've seen, but Uber in the US has just opened, something like 2 months ago, the first fully autonomous line for truck shipments. It's basically, they are just carrying goods from one coast to another. So basically, they do the easy part, which is the easy part is to have a truck that will drive a straight line across the US from one coast to another. Their trucks do not try to enter the cities and navigate. That's where it's very complicated. They just stay on the highway. And it's very interesting because in terms of competition, economical competition, I believe one of their strong points is just speed. So you see, if you have a human driver, this person needs to sleep. It cannot drive. I mean, so it cannot drive 3 weeks straight, without ever sleeping. So yes, you can have a crew with 3 people that relay, but it's suddenly, if you need 3 drivers, it gets very expensive. Plus, I mean, as you know, in terms of health, if you want to live literally 3 weeks straight in your truck, so this is a very, very competitive proposal to have like just a machine that just do this work. So transportation is getting automated. And if you look at supply chains, if you look at the very, very end, the last mile, the final delivery, it's getting automated fast. In France, McDonald's, you can see that now you can order your meal from a machine, and then you have the crew that is organized like an assembly line that will deliver your meal. So that's McDonald's, I believe, is very, very smart. They are going to double the productivity of their crew by operating like that. Interesting thing, something like 3 months ago, I was in Japan, in Tokyo, and you have many restaurants that do exactly the same. So you order from the street, you just have a nice user interface, you choose what you want to eat, BIM, you get your ticket, you enter the restaurant, and then people deliver that. You don't have a negotiation with the waiter to decide what you're going to eat. It has been taken care of by having a user interface that is accessible from the street. So this is not UI, this is not AI, this is very basic automation. But what I'm saying is that once we have literally removed almost all the people we could remove that were like blue collars, and in my terminology, a waiter in a restaurant is like blue collar. It's physical work that is expected from this person. All you have left is a lot of white collars, people that work in offices. But the question is, how much economical value do they create? So if we go back to supply chain, what does a supply chain organization look like nowadays? Actually, you have a lot of people that are going to be, let's say, that are going to do purchasing. So what do they do? Well, they are going to have a close look at the current stocks. They are going to have a close look at the deal flow pipelines coming from the sales. They are going to look at the manufacturing plans from whoever is in charge of manufacturing, combine all of that, put all of those things into a spreadsheet, and then decide what to order. And because there is so much data and specificities and everything, it takes an entire army, because you have a lot of vertical and horizontal fragmentations of the task. So what do I mean by vertical fragmentation is if you need to buy electrical equipments, pumps, cables, whatever, you will have a team specialized in electrical equipments. If you need to have like a team that buy chemicals also, you will have a team dedicated to chemicals. And if you need to have a team that buys consumer electronics or whatever, you're going to have another team. So it's going to be a lot of silos depending on what you buy. And then you will have horizontal silos, which are going to be you have a person to do the weekly forecast, a short-term weekly forecast, another person to do the mid-term weekly forecast, and then to have the long-term monthly forecast. So that's going to be 3 people, horizontal silos. You will have 1 person to decide the safety stock and whatnot. So you have like a complete matrix, operational matrix of people that we are just going to share Excel sheets. I mean, sorry, it's people say, oh, we have super advanced ERPs, but the reality is that most companies that I'm working with, even companies that are fairly tech-driven in the US, mostly supply chain-wise, they operate on Excel sheets nowadays. So you have this entire matrix of people that are sharing Excel sheets, and it's a whole army of clerks who are spending their entire lives and careers just editing numbers on spreadsheets. It has to be done. If they don't do it, the company just stopped working. So it's not like those people, they are needed. We need them. And there is a lot of insights that goes in what they do. This is true for purchasing, but sourcing is the same. Sourcing is done very manually with phone calls. You have to probe your suppliers to know if they have production capacity. You have to probe your supplier to know if they have inventory left. Or if they have manpower, etc. So it's a very, very labor-intensive job. And similarly, when you think of the whole demand chain, because supply chains is about ultimately serving market demand, so you want to organize the demand. So if you look purchasing and sourcing, it's looking backwards, your suppliers. If you look forward, your clients, it's the same thing. It's very manual, a lot of surveys, a lot of discussion if you're in B2B with your clients. And overall, it's very labor intensive in terms of exchanging Excel sheets or PowerPoints or whatever. So the way I see it is that the biggest opportunity for massive productivity improvement will be to completely radically transform what I would call those white-collar jobs. And I think where AI is disruptive is that it's going to be maybe for the first time in history that people who were working in an office are literally getting automated at scale. Because it's funny, I mean, when software enter the industry and companies, when it did not eliminate white-collar jobs. On the contrary, it just multiplied tenfold the amount of people that you have doing, white-collar jobs, tweaking Microsoft Word, Microsoft Excel, or PowerPoint documents. So clearly, it was, not a productivity improvement. They did more, but I'm not really sure that it would really qualify as a major productivity improvement. There has been interesting studies that prove that in terms of productivity, the late 90s with the introduction of computers in companies did not really improve productivity. I mean, suddenly it was more auditable. It was easier to coordinate companies that were completely global. But not necessarily, productivity did not necessarily improve as much as people expect. So if we get to that, productivity will improve, but how exactly? And that's where I think if I go back to my analogy of people that were carrying buckets, it will probably not be obvious. I mean, it will be probably quite weird, the sort of things that will happen in the next couple of decades. Usually, the best sort of AI software are typically softwares that you never see, that you never touch, that are just ambient. If you want to have, I would say, the almost perfect example of the AI-driven software is your anti-spam, for your mailbox. It's something that do things for you diligently in the background. If the anti-spam is doing its job perfectly, you never even know it's there. It's just there. It just does the work for you. And you only know that the anti-spam exists when the anti-spam fails. So when basically it captures one of your mail that was not supposed to be spam and flag it as spam, that's a failure. Or conversely, because there is a spam that hit your mailbox, and that's annoying because you have to sort it out yourself. So you see, the very good AI software is going to be completely ambient. And I think that's going to be even more true in corporate environments because companies have to pay for the mindshare of the employee. If a piece of software needs 1 hour of your attention every day, the company needs to pay you a salary so that you spend this 1 hour having a look at this piece of software. So if you think that the software, the future of AI-driven supply chain are very cool software where you have incredible visualization and stuff like that, I don't think so at all. I think, for example, to give you a taste that is more supply chain driven of what the future of software, of AI in supply chain look like, I think it's more like, the Uber pool. Have you tried Uber pool? When you can share your ride with other people. So it's just like a taxi where you jump in a taxi, that's your Uber car, but they go just where you want to go. But along the way, your driver pick someone on the way, and then so that the driver can more or less, do a nice bonus on revenues. They earn like 50% more. For you, it just marginally increase your transportation time in terms of energy consumption. Well, it's almost the same energy that is spent to drive the car. So economically, it's very, very efficient. But to manage that, Uber needs super, super smart algorithms that are highly predictive so that they can predict that the person you're going to pick is going to show up at the right place, because they want to minimize the disruption. So they need to predict that this person that you're about to pick is really going to be there because they have a good track record of showing up when they are needed, that the specific detour that you're taking is not going to double the time of your own transport. Otherwise, you will never use this feature again. So literally, it's a big pile of very smart algorithmics that are involved to get this sort of very smart behavior involved. People would maybe not qualify that as AI, but the reality is it is. It is like a very, very smart transportation planner that would real time on an entire fleet took like optimize real-time decisions on an entire fleet of cars and customers. And you have also very, very smart things that Uber is also doing, which is to conduct their fleet of drivers where they are needed ahead of time. So you see, you want to make the most of your fleet so that they are not randomly placed on the map in Paris. There should be no such thing as good spots, because it should be like a market-driven equilibrium where you have just as many drivers everywhere as it's needed. And if Uber is very, very smart, they would even tell drivers, don't show up today, we don't need you, sorry. Because it's even worse is if you show up and then you just drive in circles for 8 hours with no business. That's very, very bad. So you see, it's not economically smart. It's just wasting the time of those people who could be doing something else. So the type of super smart intelligence that we can see, or smart intelligence, because it's not that super smart, it's just like, again, optimizing transportation plans can be done by hand. The point is that it's very, very hard to do it real time. It's very, very expensive to do it real time. So in supply chain, where I see tons of opportunities for I would say, profound transformation, is all the things that will be unlocked as soon as companies have put their IT infrastructure in order. You see, the very smart companies like Amazon, they have made themselves amenable to artificial intelligence 15 years ago by having APIs. Anyone knows what is an API? Application Programming Interface. Yeah, there are people that know. Who knows? Yes. So the idea is that you can, if you don't have ways to programmatically extract all the data that are relevant, and then to inject, automated decision in your organization, it's very, very hard to inject any degree of AI. And Jeff Bezos, in a very, very famous 2002 memo, was extremely smart. He said basically, everyone, we need to have APIs all over the place so that there is no more any data silo, so that suddenly it becomes possible to collect all the relevant data, which are not like, Twitter feeds or anything. It's usually very simple data, transactional data of who has what in terms of inventory, who has spare capacity on anything. Just make all the data that are relevant to your business accessible to all the other departments. And that should be like a default move, not just something that is an afterthought. So once you've invested into your IT infrastructure so that you have your API, by the way, an interesting corollary is that you need to completely distribute the IT competency in your company to do that. So if you have like an IT department that is heavily centralized, it's incredibly difficult to make this happen, just because the IT department just becomes the bottleneck of every single initiative, transformative initiative in the company. And it's very funny because I've seen many clients in supply chain, in our clients, where, for example, if they want to move from one warehouse to another, the problem is not at all the moving physically stuff from one warehouse to another. This could happen over a weekend. It's easy. But moving all the IT setup, software setup from one warehouse to another can take a year. So it's the software migration that takes a lot of time that is a complete bottleneck, not the physical thing. So if you want to have any kind of very smart automation, this very smart automation needs to have access to the data. And nowadays it's very interesting, but the algorithm that we have, they require a lot of plumbing. You know, if you want to plug anything like a smart algorithm in your company, if you don't do it carefully, what you obtain is always the same thing: garbage in, garbage out. And because your AI doesn't have any common sense, it's just a statistical learning. It will just learn to mimic whatever inputs it has observed in the historical data. It will do that very diligently, very efficiently. But in the end, it's just about, you know, it's a very, very narrow sort of intelligence, which means that whenever you are giving garbage as input to this intelligence, it doesn't have any common sense. You know, even an employee that is not very, very smart would realize, but I'm supposed to buy electrical equipments, and the list of products that I see here are not even electronic equipment, so it doesn't make any sense. Maybe there was a confusion on the category code. You're showing me chemical products. Doesn't make any sense. An AI is not going to have any common sense. You just have your purchasing AI that is incorrectly plugged into the wrong product category. It will buy very, very stupid things. And so nowadays, by the way, all those smart automation, when there is like money involved, it still requires human supervision. But instead of having somebody who do all the critical work on Excel, it requires something that is more a competency that is akin to data scientists, or what we call that Lokad supply chain scientists, who are basically people who are given very powerful tools that are kind of AI driven, but also we see that more as powerful mathematical and statistical primitives that can be operated by a specific class of engineers that have the right training to use those tools. So it's not like you have this AI that lives autonomously. It's typically more you have building blocks that are widely accessible, easily accessible. They can live in the cloud for many reasons, such as access to processing power. But you have classes of people that are typically what we refer as supply chain scientists in Lokad that supplement your narrow AI with human intelligence so that there is such a thing as common sense that is available. So sorry, it's a long digression, but you see, in terms of AI and supply chain, the situation that we will see, I believe, will be a profound transformation where most of those white-collar jobs that are not really adding value, where people are more like, you know, OPEX and CAPEX. You see, do you see people, when you pay the salary of a person, is it OPEX or CAPEX? Do you need to pay this person so that your company keeps working? Or do you need to pay this person so that you're investing in the future of the company? And I think if you look at the very, very smart US companies that are literally going to bring the revolution about supply chain, you know, Amazon, Uber, Google, whenever they want to hire one more employee, they are really always thinking CapEx. This is an investment. This person is an asset. It's going to literally increase the value of the company because it's a profitable investment. And it's going to be a capitalistic investment. Every month, I can pay this person, I am increasing the value of my company. This is the exact opposite of OPEX, where it's just a cost, and I am consuming the time of this person just to keep the company operating. And by the way, this line of thinking is really not new. IBM in the 50s were already saying, having a motto that was, we do not pay people to compute, we pay people to think. We have machines to do the computation. So it was a very old line of thinking, you know, that dates from the very, very early days of computing, actually, mechanical computing. And I suspect, you know, that those supply chain will be transformed in ways that are unexpected, in the sense that it will be more about transforming your company so that this level of automation and intelligence becomes possible. Which, by the way, is very, very difficult at the strategic level because it completely challenges the status quo. Just to give you one anecdote of what sort of problems, challenge you have when you want to inject AI in a real-world supply chain. Just think an anecdote for a retail chain we're working with. You want to optimize how much stock you put in a store. Okay, so basically you build an algorithm that tells you, according to the historical patterns of demand, how much do I need to have just enough stock so that I can avoid stockouts. Good. The algorithm is going to give you an answer to that. Problem is, in a store, the stock serves two purposes. The first purpose is to make sure that when people want to buy, they will find the product available. So that's basically servicing the demand. But then stock serves also a second purpose, which is merchandising. Your store needs to look very appealing to your clients, so it needs to be completely full of stuff. So and that's the merchandising angle, because if you have a store, you have a store that is like completely depleted of inventory, it looks like, you know, USSR, like like the store that is completely not appealing. Is it like do we have a shortage or something? It's not appealing. So it means that if you're just, you know, using an algorithm to drive the stock naively, it will just drive the stock just enough, but it's not going to be appealing. So what do? You say, okay, I have this level of stock that is a servicing stock level, what I need to spend supply chain-wise. But then guess what happened with supply chain? Supply chain say, oh, you know, all the stock that is on top of the servicing stock, that is only needed for merchandising, as me being the supply chain division, I don't want to pay for this stock. This should not be on my budget. This is a marketing spending. So because this is what about? This is about generating demand, so just like spending money on TV ads or anything. So the challenge suddenly becomes, you know, a tight strategic, I would say, infighting between supply chain and merchandising or marketing, because suddenly there is it challenges the status quo on who is going to carry the budget. You know, in the old world, that was the supply chain was happily carrying the budget of inventory for everyone, but in the new world, there is part of a budget that is on supply chain, and part of a budget that is on marketing. And my own experience is that this sort of strategic negotiation takes a lot of time, and they are difficult because it's profound changes. It typically challenges things that have been in place for decades, for large companies, maybe for half a century, for the very large ones, and it cannot happen very swiftly. I mean, there is a lot of, I would say, edge cases when you try to roll that into production. You realize there is a lot of untold knowledge that was not really in the systems, and then you realize that you have tons of things that were what I called shadow IT, meaning that it's, I'm not sure if anybody is familiar with this idea of shadow IT. They are the softwares that everybody uses, you know, officially, supported by IT, and then you have the Microsoft Access database that is used by a team, you know, but they don't tell anybody about it. They just use it. It works well. It has been working like that for 2 decades, but they don't tell anybody about it. And according to, you know, corporate guidelines, they're not even supposed to do that. And the very funny thing is that one day, just to give you one more anecdote about this shadow IT, sorry, it's so many digressions, but I just discovered that there was a team that had like their own private secret within large company Access database. And I asked the manager of the team, do you have everything in this Access database? He said, yeah, my team, we are all on that. And then a couple of weeks later, I was discussing with an employee that was under this person. And this employee told me, oh, but the boss, he has this Access database, but you know, it cannot, you know, manage all the edge cases, so I have my own. That is secret. And I've not told the boss about it because the boss says everything should be in the Access database that is used by the team. So you have like shadow ITs within shadows. It's something that happens very frequently in large companies. Back to AI, it means that all those things like shadow IT, status quos that are challenged by the very fact that you're suddenly going to take a more quantitative stance on all those problems, they are tremendously difficult governance challenge for the company, conduct of change. I mean, it's really a big thing. And our clients typically, the number one most difficult thing that kills AI-driven supply chain, because if I want to use buzzword, what Lokad does is to put supply chain on AI autopilot. I mean, it's a buzzword because really it takes a lot of human intelligence, like entire teams of supply chain scientists to make this happen. But that's pretty much the buzzword-ish way to frame what we're doing. The number one challenge is to get access to the data that is relevant so that we don't get garbage in, garbage out. And once we have done that, the second biggest challenge is to conduct a change which runs very, very deep. And it's very domain specific. So I believe, I don't know, I think that's, maybe it's time for questions. I invite the audience. So Lokad, I hope that we will play our modest part in pushing the history of AI forward in supply chain. You know, AI, the research in AI has been heavily dominated by, I would say, the big problems. Natural language processing, image recognition, speech recognition, that were the big, with big B, big P problems. Forecasting demand, optimizing promotions, avoiding inventory to be wasted because it's perishable, etc. Those are, I believe, for mankind, big problems as well. Economic sustainability, but from AI, they are currently seen as relatively minor secondary problems, which do not attract as much attention from the research community. So I hope that Lokad will, you know, make a small dent in history and push AI a bit further on those problems that I believe to be of great interest for. I mean, people say climate change, etc., but you know, the easiest way to avoid pollution is to not produce stuff that you don't need in the first place. That's where Lokad can help. You know, so you don't waste energy extracting stuff from the ground. You don't waste energy transporting the stuff, and then you don't waste energy and destroying the thing, creating pollution at the end of your supply chain with stuff that you never needed in the first place. So that's where we can help. More specifically for companies, typically what we do is we say, I would say, a bit like a Jedi motto, you know, do or do not, there is no try. Lokad, we are very lean in terms of cost. We are not like, let's say, some enterprise vendors that require several million euros up front. We can start with very little, but it's a journey. So typically the way we help them, we say, what do you want to do is typically if you want to achieve what we call quantitative supply chain. So a supply chain that is grounded in quantitative optimization that is not like naive finance. It's not just about optimizing euros naively of profit. You want to be forward thinking and say your customer karma, you know, the karma that you can gain with your customers by being a brand that is really recognized for its service and everything, this has value. If you intend to stay in the market for decades, you should probably make that part of your calculation. Otherwise, you're just going to be like doing only short-term moves. So Lokad, we are very lean. And as a software, there is two angles. We have the software platform that let people execute, you know, the number crunching per se. But it's only one angle of what we do. We typically sell a service like a monthly subscription. It's very basic, where we provide the supply chain scientist. We are growing a big supply chain science competency at Lokad in Paris. Those people will play the role of, I would say, a guide and an orchestrator and even somebody who is going to execute these initiatives for you. And typically large companies, they want to get started with tapping a lot in the supply chain science resources of Lokad to get started faster. So you see, you have software, you need competency, so you want to get started fast, so you will start with people that you will get from Lokad, but with, I would say, a 2 years roadmap of re-internalizing most of this competency because they don't want to ultimately to depend from a competency that is from a company that is outside, because supply chain is really the core. I mean, for many companies, producing and serving the market is a core competency, so it cannot stay forever trusted to a third-party company. Does that address a bit your question? But so basically somebody says that it's very flattering that they have never seen a website with so many pages that describe in so much detail all that what we do. And it's interesting but also intriguing because we are opening ourselves to competitors who could literally steal everything from us just because it's right there on the website. So yes, I agree. We are opening ourselves completely to being completely copied by competitors. That's, yes. Here, I believe that it's very interesting because when you see an economy that is driven by, AI-capable software, software that are very, very smart, suddenly the economy transforms into something that is a bit different. Where there are some aggressive venture capitalist fund in the US that think that the economy will evolve more and more into what they call systems of intelligence. So the idea is that access to the knowledge has become very, very cheap. Wikipedia was a game changer. I mean, there is tons of super technical knowledge that is just available at your fingertips if you just look it up on Google and you will find a page on Wikipedia about it. So if you assume that access to knowledge is not going to be a lasting defense for your competitive advantage, what will? That's a question, what will be your competitive advantage, your lasting competitive advantage if access to knowledge isn't? And they describe, there is one theory, I think there is a couple of funds who are driving their investment according to this theory, is they describe as system of intelligence. Because the reality is, it's so hard to replicate a team of supply chain scientists. Lokad is growing at 50% per year, and people don't really realize what it entails. It means that half of the people that are in my company, we are like about 40, they have been there. The median is of age for the employee is like 6 months. So you see, when you're growing at 50% per year, and there are some companies that are growing way faster than that, the median age for your employees is 6 months. Literally, every person at Lokad, I mean, half of the staff is under période d'essai, French jargon, it's like trial periods. It's, I mean, it's incredible. I mean, as an entrepreneur, it's incredible to see the company growing like that. It's very satisfying, etc. But when it comes to competency, even if you hire the best people that are brilliant minds that learn super fast, I mean, there are limits to what you can ask to a very, very smart engineer. I mean, even super smart engineers, it still takes a couple of months to be, to acquire some competency. And if they want to be really, really good, it takes multiple years. So why do we publish that? Is because we want to attract, we want to outcompete competitors on making ourselves more attractive as an employer. So this is the employer brand that I'm building. It's not really for the client. The clients, they like seeing tons of things, but the thing is that most clients, they are going to make a phone call to say, you know what, you have probably 300 pages of documentation on the website. It's very interesting, but let me say, I will say it straight, I didn't read them. So they directly jump into a phone call with us, and maybe a tiny few prospects will read a few pages, but most of them will say it's very impressive, but they will never read it. The funny thing is that the people who will read it are people who apply to Lokad. They say, oh, I'm applying to your company because it's so interesting, there is so much to learn, and I'm even bookmarking your website because I want to become a supply chain professional. And I'm bookmarking your site so that I can stay up to date with what you guys are thinking as, state of the art. You're not the only people in town, but you're certainly people that are worth being bookmarked. So this is the end game that I see in outcompeting. It's all about education in the end. And I believe those AI will reshape really the supply chain industry, because companies will compete on education, on system of intelligence, on how they are collectively smart. Like, lot of people that are not just individually smart, but that communicate so that they can do something that is highly, highly collaborative. Because you see, in supply chains, people are saying, we want to have like better supply chain, but usually it means more collaborative supply chain, but you need to bring all those smart people aligned, and it takes a lot of efforts, and if you have like common frameworks, common terminology, it really helps. So that's my angle. But for me, when the stock is not moving, is that there is a failure of being diligent at taking action for the next step. So literally, it's not moving because you depend on the bureaucracy, which is you're going to have a stamp approval of something, and it's going to take time. So the way I see it is that most of the time it's productivity in design, but I agree, it's a simplifying angle. You're completely correct. And then you want to have complete traceability. You might have regulations that complicates for good reasons or bad reasons, depends. So I completely agree. It's not a one-dimensional problem. It's a very, very many-dimensional problem. I completely agree with you. I mean, if I'm not betraying your thinking. So yes, Amazon has been very quiet, stayed very quiet on this for years. But last summer, it's very interesting, they finally decided to go public, and they made a series of publications on the algorithms they were using, and they have been using it for years. So it's very, very interesting. I believe that Amazon is now playing the education game, and they want to attract. So, because there is also this part is we publish a lot of things on Lokad, but we not necessarily disclose the latest thing. So there is a timing angle. So Amazon has gone public. You will find they have deep learning algorithms. They have publication, in scientific conference, where they describe, for example, the deep learning algorithms that you use for demand forecasting. And they are using probabilistic demand forecasting, just like Lokad. So we are flattered. We co-invented separately, both Amazon and Lokad, probabilistic forecasting for supply chain. So they are. The paradox is most of the clients we are dealing with, the first thing they do is when they sign a contract with us, they let us sign an NDA, not just to protect their data, but also to make very sure we will never tell anybody, if it happens to work, that it works, because they see it as a competitive advantage. So it's not exactly viral marketing. It's pretty much the opposite of viral marketing. And just to give you an idea of how we are actually winning clients in aerospace, because we have a lot of clients in aerospace, so far the only way we win clients is we have someone who was working in a company who was using us. This person just moved from one company to the next, because it's a tight industry. People move a lot from one player to the next. And in the next company, they're carrying Lokad in their luggage. So that's the way we win clients in aerospace and in some other industries as well. But just to give you some indication of the type of companies that are the most eager to do that, they are typically the very tech-driven e-commerce. So just look in Europe. If you look at who is investing heavily in tech, in Europe as an e-commerce, chances are there, I can't give names, but look at the very, very, very aggressive people that are literally investing a lot in tech, in e-commerce. They are typically people that are either using us or in discussion with us. In the US, we have our best market segments are smaller companies. So they have, in Europe, I don't know, through proximity, we are actually live with relatively large players in e-commerce. In the US, it's smaller companies. They are typically companies who are operating on marketplaces. So they don't necessarily have their own brand, but they resell through Amazon, marketplace. They're using FBA. They are purely digital companies. So they dynamically source stuff from Asia. They don't even have their own facilities. They're like pure digital company. They buy stuff automatically from Alibaba. They send this stuff through FBA to the warehouses of Amazon, and they want like complete end-to-end automation and make their cut, almost like quantitative traders. So they are not that large, but they are growing very fast, all those segments. And they are typically the sort of people who are very, very eager to use us. But I mean, privately, not in this video, but privately, we can give you a few names and intros. But sorry, I can't disclose that. It's going to go on YouTube. So. I would not claim being an expert at this. Leaping forward is very difficult. My own background is mathematician. So please take my claims. I think I can make very reasonable claims about algorithmics and future of AI in general sense. When it comes, because I believe that you're a supply chain practitioner yourself, you've helped organization as you were describing. So please, excuse me if my answer is not top notch. What I see in my clients, I see the American way that is extremely brutal. The American way of conducting change is just having, Jeff Bezos is famous for that. He just sent company-wide memos that says, literally, that was the memo I was referring to in 2002 about APIs. The memo was literally stating, every managers need to have an action plan ready for me in 2 weeks. Everybody who do not will be fired. Thank you, have a nice day. That was literally the content of the memo. So, and he literally fired tons of people 2 weeks afterwards. So that was like brutal. I do not know if it's really, because from my European perspective on that, it's very, very brutal. And it's a bit the recipe to have people that are very unhappy at work and with unhealthy dynamics in the company. So I'm not sure it's the end game of doing it that way. I do not know. But again, Bezos was a younger man that he was at the time. He's probably more smooth as those there, or maybe the opposite, I don't know. Anyway, so that's the European way, and I see that happening in the US. In Europe, what I see is people taking their time to conduct a transition in 2 years. So basically, we have companies that just, Lokad is ready and running, so the software is running, it's production grade, but it takes 2 years to deploy because they are taking a very, I would say, slow approach to transition everybody. And I believe, there is wisdom in that also, because you see, the trick is that if you transition super fast, you are taking the risk of losing some knowledge, insider knowledge that you have not identified as such. You might think that this person is just doing dumb Excel sheet, but it turned out that this person had some uncanny insight about the company. So I'm not sure, clearly things are happening a lot faster in the US, but they tend, what we see with our clients, but it tends to generate a lot of unintended side effects. Companies in Europe takes a lot more time to do it with a lot less side effect, but they are late to the party always. So I don't know, this is beyond, I'm not a grand captain of industry. I'm just a modest mid-sized business entrepreneur. So that's, but I hope, by the way, Lokad is a tech company, so I really hope we'll be help with people that have competencies like you just to figure it out, because I did not figure this out yet. So let's start by just the sort of things that I would suggest not to do. First, don't hire AI PhDs or machine learning PhDs. This is really the wrong angle. I've never seen in all those tech, it has to, and from my own observation, it has to start with a business problem. So it cannot start any other way from having the CEO on his board that say, this is a strategic angle, we want to do this thing better or faster or leaner or whatever. But it has to start with a problem with euros of dollars at stakes. You don't do AI because it's cool. It's just like blockchain. You don't do blockchain because it's a buzzword. It has to be very, very grounded in a core fundamental problem, and ideally a problem that will not change. Focus on what do not change. Very, very good brands like Vuitton, they think of what do not change, that they have an image that is supposed to be like immutable or getting better. It's not supposed to be even disruptable. If you have an excellent brand, no tech should be able to disrupt this perception of the market. So they focus, so I would suggest so first don't hire, people that have like the latest flavor of machine learning skills. It's dramatic. The domain is changing so fast that even if you hire a PhD, in 3 years, his or her knowledge will be out of date. So it doesn't capitalize. My positive advice I would suggest is get yourself familiar with your data landscape and your applicative landscape. You see, I'm not asking for you to become an expert at programming as a CEO. You don't have time for that. But you need to know who has the data. And with GDPR, is this data an asset or a liability? Because people tend to confuse the two. So a data can be an asset if you can make more business out of it. If you're just exposing yourself to a data leak that will be extremely costly, this is not an asset, this is a liability. So I think again, AI is fully data-driven. We do not have anything but data crunching algorithms. So it's all about data in the end. So, and the type of algorithms are typically extremely horizontal algorithms. So the thing that works for one industry tend to be the same thing that works for another. It's very, very generic, like computing. It works. So the thing that is not generic is your data. So my suggestion for the CEOs or strategic advisor, extra, would be you have to know all your data sources. You have to know if there are silos, if data can, I would say, is fluidly move from one part to an organization to another, or if you have like things that prevent that from happening. And you have to be kind of familiar with what I would say the applicative landscape. So what sort of applications are capable of crunching this data, or having access to this data. The problem with IT is that you have so many incompatibilities where, in theory, everything is compatible with everything. That's the theory. That's what the enterprise software vendor sells you. The reality is that whenever you ask, your IT guy, you say, oh no, this app not compatible with this thing. So it's a manual. It goes through a spreadsheet that is manually extracted here, re-imported there, and it's a big drag on everyone. So I think if you want to be really good with AI, yes, being more familiar with the landscape and probably read a few things about high-dimensional statistics. Forget about chasing the latest flavor of the day. It's more about what does that mean to have a statistical model that operates in a high-dimensional space. You can probably have a 3 hours self-taught session on the Wikipedia reading the page that you will learn more about AI than most TED Talks about AI if you do that. Thank you very much. And I would like to thank, maybe as the concluding remark, the Franco-British Chamber. It was a pleasure being there. For us, Great Britain is an asset. We even have 2 employees that are from Great Britain here. And really, they are, I would say, key assets, for Lokad. So I'm very, very glad to have them on board. And I think despite, the Brexit might have happened, but the way I see it is that Europe is increasingly integrated, and we are very, very proud to be part of, this big market, and we have very strong ties with Great Britain. And I see, even if Lokad is based in France, we are very good clients in Great Britain. And I see, the Franco-British Chamber of Commerce and Industry. Thank you so much for inviting us today. Thank you very much.